Hi everyone, I'm Mario and welcome to Code on Fire. In this tutorial we will see how to create and use different resources, such as the timeline, by creating an elevator ready to be used in a project. First of all, let's create an actor blueprint. Go to Content, right-click, Blueprint, and finally choose an actor blueprint, which we will call BP_elevator, or lift, as you prefer. Double-click to open the blueprint, add a cube, and scale it to create the base of the elevator. Rename it as elevator. Make sure it has a value of 0 on the z-axis in the location component. Next, add more cubes, scale and move them to create the walls of the elevator. Keep arranging them. Finally, add another cube that will be the door. Adjust it by scaling and moving it to the correct position. Set the door's X value in the location component to 0. This way, moving the door along the x-axis with a starting point of 0 will make it easier to set up the correct movement. Rename it as door. Walls and door should be children of the elevator, so let's establish this parent-child relationship. Add two box collisions. The first one we call outer box and place it like this. The second one will position inside and call inner box. Once finished, you should have this exact setup. This should also be children of the elevator, so let's set up the parent-child relationship correctly. Now, let's move to Event Graph and start implementing the logic. Add two event nodes, an onComponent begin overlap for the outer box and an onComponent end overlap also for the outer box. With the outer box selected, go to the Details window and click on onComponent begin overlap. Similarly, add the end overlap. Drag a connection from the onComponent begin overlap and link it to the character. Since we are in a third-person project, we'll search for a custom third-person character node. Duplicate this node and connect it to the onComponent and overlap as well, like this. Add a comment, write door open close. At this point, we need a timeline to create the door animation for opening and closing. Right-click and search for timeline. This will be useful to make sure the door's movement is not instantaneous, but happens over the time we set in the timeline. Rename the timeline to open close. Double-click on the timeline and create a new track by clicking the plus button. Choose a float type. In length, set the time the timeline will take to complete its path. Let's use a value of 2. With the cursor on the timeline, right-click and then click Add Key to insert a new keyframe. In time and value, set a value of 0. Add another keyframe, right-click, Add Key, and this time set a value of 2 in time, a value of 1 in value. This means that after 2 seconds, the timeline will reach the value of 1. We'll use these values to create the door's movement, as we'll see shortly. Rename this track as open close. Let's go back to the event graph and connect the play of the timeline to the begin overlap and reverse to the end overlap. This will allow the door to open and close when our character interacts with the outer box. Now search for the set relative location node related to the door and connect it to the timeline. On the timeline, we see the open-close pin, which refers to the track we just created. Drag a connection from this pin and search for a multiply node. On the set relative location node, right-click on the new location pin and click Split Struct. Since the door will move along the x-axis, as we can see in the viewport, connect the multiply to the new location x pin. In multiply, set a value of 60. This way, when the timeline reaches the value of 1, it will be multiplied by 60, moving the door along the x-axis by 60 centimeters. Now we are ready for a first test. Let's go back to the game scene and place the BP elevator inside it. Go to play and as we can see, the door will open and close when interacting with the character. We also see that the door moves to the center of the blueprint. This is because the door's reference for the Y and Z axis is the blueprint, which has 0 values for Y and Z at this point. To avoid this shift, go back to the event graph, search for Get Relative Transform, and use the door as a reference. Right-click on Return Value, Split Struct, and then on Location, Split Struct. Connect the Y and Z values to the new location pins of set relative value. This way, will provide the door's position on this axis and prevent it from shifting. Go back to the game scene, go to play, and this time everything will work correctly. Let's go back to the event graph. Move to this section and insert the event nodes on component begin overlap and on component end overlap related to the inner box. From the begin overlap for the inner box, we'll move the camera so it gets closer to the character when they enter the elevator, allowing us to see inside. Also in this case, perform a cast to the character and connect everything. Add a comment to the on-component begin overlap for the inner box and write move camera. From the pin as BP third-person character, drag a connection and search for the camera component belonging to this class, the follow camera, which we will use as the target for the set relative location node that will connect to the cast third-person character node. In new location, set the values to 300 for X and 50 for Z. As we can see in the BP third-person character, we need to move the camera along the X-axis to get closer to the character and along the Z-axis to raise it a bit. For the on-component and overlap, perform the connection to the character, add a comment, and write reset camera. Here we reset the camera position to its original state when the overlap with the inner box ends. Select these nodes, duplicate them, and connect them to the on-component and overlap, setting the new location values to 0 for all three axes. Let's test everything, and as we can see, it works as expected. The camera moves closer and farther from the character based on the collision with the inner box, but the walls and door collide with camera. Therefore, let's go back to BP_elevator Select the walls, search for collision in the details window, choose custom and check ignore camera. Repeat this operation for all parts. Compile, save, return to the game scene, go to play, and this time everything works correctly. Now let's make the elevator go up and down. Let's go back to the event graph. I'll choose to activate the movement by pressing the T key, but you can choose any key you prefer. Search for the input in the keyboard section, drag the connection and search for a timeline, which we'll rename Move Elevator. Double-click it. In length, set a value of 8 seconds. Create a new track and call it Close Door. Right-click, add a keyframe with a time value of 0 and a value of 1. Add another keyframe with a time value of 2 and a value of 0. This way, the door will close. Add another keyframe with values of 6 and 0, and finally another keyframe with values of 8 and 1 to reopen the door upon arrival. Create a new track and call it Move Elevator. Add a keyframe with a time value of 2 and a value of 0. Add another keyframe with a value of 6 and a value of 1 to move the elevator up or down. Let's go back to the event graph. The input will make the elevator go both up or and down. So add a flip-flop node and connect output A to the play of the timeline and the reverse to output B of the flip-flop. This way, pressing the T key for the first time will make the elevator go up. Pressing it again will make the elevator go down. Add a comment and write Move Elevator. Let's add a set relative location node referring to the elevator component, which is the base of the elevator. Split the new location pin and, starting from the Move Elevator pin of the timeline, connect a multiply node with a value of 400 and link it to the new location Z pin. This way, the elevator will move up or down by 4 meters over the time set in the timeline. Now move to the door open-close section, duplicate these nodes and connect them so that the door can open and close. Compile, save and go back to the game scene. To test our elevator, we need to create another floor, which we'll do by simply adding a cube by clicking the plus button, Shapes and Cube. Scale it and go to the Details window. Since the elevator will move up by 4 meters, set a value of 400 for Z, which should be about right. Align it correctly, go to play, enter the elevator, press the T key, and as we can see, nothing happens. This is because the input is not enabled. To enable it, go back to the event graph. At the onComponent begin overlap node for the inner box, connect the enable input node, search for it and connect it. In the player controller, connect the get player controller to prevent the elevator from moving when we are not inside it. At the onComponent and overlap node for the inner box, connect the disable input node, connecting the get player controller to it. Compile, save, and return to the game scene. Go to play, and we see that the door opens. The camera moves. Pressing T makes the elevator go up. Upon arrival, the door opens again, and when we exit the elevator, the camera returns to its original position and the door closes. Now repeat the operation by pressing T again, this time making the elevator go down. Let's add another feature, a text that appears when we enter the elevator to tell us which key to press to move the elevator up or down. To do this, go to Content, right-click, User Interface, and create a widget blueprint that we call WGT Info. Double-click it, add a canvas and a text. In the text, write press T to move the elevator. You can change the color if you like, compile and save. Return to the event graph of the BP underscore elevator. At the onComponent begin overlap node for the inner box, connect after the enable input node the create widget node and set the class to the widget we just created, WGT underscore info. Finally, connect the add to viewport node, searching for it like this. To make the text disappear when we exit the elevator, at the onComponent end overlap node for the inner box, add the remove from parent node, connecting the target to the return value of the create widget node. Compile, save, and return to the game scene. Go to play. Entering the elevator, the text will appear, providing information about the key to press to move the elevator. When we exit the elevator, the text will disappear. That's all for now. We'll revisit the topic to see variations on this theme and more general uses of the timeline. So, subscribe to the channel. Thanks for watching.